All right, hello everyone again. Hope you are making your adjustment to doing this distance learning. I know I'd much rather have you guys in class. I miss seeing you guys. Feel free to email questions if you have them, of course, and even if you just want to say hello, I would love to hear from you. But 10.4 day 2 today. So I'm going to start off with an example, and then we only have two main ideas to look at. And one of them is going to be classifying a conic, and we'll get to the other one in a second. So first example, it's going to ask us to find the standard form of the equation of a hyperbola having these two vertices, -3, -2, and 15, -2, and having asymptotes of y equals 2/3 x minus 6 and y equals -2/3 x plus 2. So again, like I kind of did yesterday, if I took the word hyperbola out of this, would you be able to tell that that's a hyperbola? And so hopefully you would say yes as of now, because the only thing that we have that has asymptotes in it are the hyperbolas. So the fact that it says asymptotes tells me, yep, this is definitely a hyperbola. All right, so I'm going to start with the fact they gave me both vertices. So I know that that means it's telling me what the center is. So I'm going to find the bin point. I'm going to notice that it's x that changed, not y. So I know the y value is -2. And to find the midpoint, I add those together to get 12. Divide by 2 would give me 6. So I know my center is 6, -2. So in terms of going to set up my equation, which I'll do in a second, I've got the center. Now I also know that these are the vertices. So the distance between this center and either one of those vertices is a. So from 6 to -3, that's a distance of 9. Maybe I'll double check it. 6 to 15, yep, that's a distance of 9. So a is 9, which means, of course, a squared is 81. And then because that's x, that means that x should be the positive term. So if I wanted to go to set this up, I pretty much have everything I need already. I have x minus 6 quantity squared over a squared, which I actually know is 81, minus y minus a -2 or plus 2 quantity squared over, I don't know what b squared is yet, and it equals 1. I have almost everything I need. I'm just missing b squared there. I've exhausted the vertices. I got the three things that told me. So now to get b squared, it must be coming from the asymptotes somehow. So now when I go and I take a look at the asymptotes, the thing that you are interested in when it comes to the asymptotes is the slope. I know the slope of those asymptotes is equal to plus or minus 2/3. Now, if you remember what we were talking about yesterday, and when we looked at the graph and how if I had my little rectangle, if I know what the center is, that means that I'm going up 2. Remember, it's always rise over run. I'm going to be going up 2 and to the right 1, 2, 3. So I'm going up 2 and to the right 3 to get this point, and then up 2 and to the left 3 to get that point. That's kind of how that would work. So I'm going to use that idea and say, okay, well, wait a second. If I know that the slope is equal to 2 over 3, and according to this equation, this represents a squared. I know that because I found it from over here. That means whatever's missing over here, that's b squared. Well, that means I know a is actually 9. I don't know what b is. But whenever I find slope, it's always rise over run, which means it's always the change in y over the change in x. There's y. That means the slope of this equation would be this denominator, the square root of it, divided by that denominator, because that's the y term. That would tell me how far up or down I'm going. The number under the x, that tells me how far right or left I'm going. My slope for the asymptotes, I know, is plus or minus 2/3. On my equation, the slope is going to be b, whatever that is, divided by 9. And again, I always know that slope is rise over run. So it's always the y value divided by the x value. If the y term had been here, I would have said it was 9 over that number. All right, so now I've got that plus or minus 2/3 is equal to b over 9. I can go ahead and cross multiply from here, and I'm going to get 18 is equal to, I realistically am going to get plus or minus 3b. I can divide both sides by 3, and I find out that 6 is equal to b, or b is equal to 6. Now, like I said, realistically, this is plus or minus. When I go to plug it in here, I'm going to square it, so it ends up turning into a positive number anyway. So if you ignore the plus or minus, you'd actually be okay, because it's not going to affect what happens with your final answer. So again, a little bit different. I think this part was probably okay. We did that yesterday, and you got some practice with that, finding the center, finding the fact that this is positive, so I know the x term is positive. The thing that's different is I know the slope. They told me the slope was 2/3. I have to look at this and understand when I've got these numbers, my slope is going to be the y value divided by the x value, so it should be 6 divided by 9. I didn't know that that was a 6, so I said it was b divided by 9, or you could say d or f or whatever variable you want realistically. I want to use a and b just because that's what they represent. I know that's a because it's the positive term. That would be b because it's the negative term. So I know that this was b over 9, and then I cross-multiplied and solved. You're going to get one like this toward the end of the lesson today, except they're not going to give us the vertices. They're going to give us the foci, and you're going to see we're going to do kind of the same thing, but it's a little bit more difficult of a problem. All right, so just a little bit of a practice problem. Here's one of the main ideas for today, and that is classifying a conic. You'll love these questions. They go very, very quickly. You can usually look at them and within 2-3 seconds tell what the answer is if you know what you're looking for. So classifying a conic from its general equation. So the graph of, again, this is the general equation when equals 0. Ax squared plus cx, or cy squared plus dx plus ey plus f equals 0 is one of the following. Now, I don't tend to use these. I'll tell you what I look for, but if you want to use these, great. If you want to do what I do, great. It's up to you. In order for me to have a circle, ellipse, hyperbola, that means I have to have two squared terms. So really, we're only looking at this. This does not affect anything else. It might affect the shape of the ellipse or where exactly the circle is, but it doesn't affect whether it is a circle. It doesn't affect whether it is a hyperbola or whatever the following. So it is a circle if basically those two numbers are the same. If they're both squared terms and I have 3's in front of both of them, that means it has to be a circle. So that's what that is saying. It's a parabola if a times c equals 0. What does that mean? It's a parabola if you only have one squared term. So say you just had a y squared term, that means a equals 0. So of course 0 times anything would be 0. They can't both be gone because then you don't have any squared terms. It's not going to be any sort of conic. It's going to be linear. So if you have two squared terms and they're the exact same number in front, it's a circle. If you only have one squared term, it's a parabola. Or again, you can follow this rule if you want to. An ellipse would say a times c is greater than 0. What that is saying is that these are either both positive or possibly both negative. They're not saying that they're the same number because that's what a circle is. So if you saw a 9x squared and a 3x squared or 3y squared, you know because those numbers are different, it's got to be an ellipse. Now you heard me say, what if they're both negative? Imagine if you had negative 6x squared plus 11y squared, whoops, it's minus 11y squared equals, doesn't really matter. All you'd have to do is move these two to the right side of the equation, and now they're both positive. So it would make that an ellipse. So again, if you want to use this rule, great. Me, I don't tend to do that. If I see there's two squared terms, the numbers in front have the same sign, usually positive, and they're different, I know it's an ellipse. And then for a hyperbola, I know the only way that's possible is if one of those squared terms is positive and one of the squared terms is negative, which means when you multiply them, you get a negative number. So like I said, up to you. If you want to memorize these, that's great. If you want to do what I do, just look at the squared terms and go from there. That's great. It's up to you. So this next example is going to ask us to classify a couple, and I'm just going to write down a few of them. So I'll quick write down 4 of them, and then we can go through and figure out which one is which. So for letter A, I'm going to say x squared minus 3x plus 2y is equal to 5. For letter B, I'm going to say that 3x squared minus 5x plus 13 is equal to 4y squared minus 7. For letter C, I'm going to say that 6x squared minus 5y squared plus 2x is equal to 6x squared plus 11. And for letter D, I have 7x squared minus 7y squared, plus 7y squared plus 11 is equal to 19 minus 4x. So I've made them more complicated than you would probably see. But the idea on the first one, that one's much more simple and straightforward. You can look at this equation, you're going to say, oh, there's only one squared term. That's easy. That means it has to be a parabola. Doesn't matter if it's positive, negative, we don't care. If it's only one squared term, we don't care if it's x, we don't care if it's y. It's got to be a parabola. The second equation, if you notice that you do have more than one squared term, they need to be on the same side of the equal sign. So I would need to either move this squared term over here or this squared term over here. If you do that, I have a positive 3x squared here. I would move this over and make it a negative y squared term. One positive, one negative. It's got to be a hyperbola. Like I said, you can see that I can identify that fairly quickly without having to do much work. So for these, there's really no work to show unless you want to do the same thing that I'm doing where I just underline the terms that I'm looking at. For this one, I look at this and say, oh, there's an x squared. Wait a minute, there's an x squared too. So I need to move them to the same side, and I recognize they're going to cancel out. The only square term I have is right there. If I only have one square term, it's a parabola. Now, like I said, you're probably not going to get equations where they have stuff on all sides. They'll always be on the left side or the right side, and you just have to look at the squared terms. But obviously, you can make it a little more challenging. And then this one, there's no squared terms over here, so I can just ignore it. There are the squared terms, both positive, both have the same number in front. This is a circle. If I had changed this to 17, then I would change that to an ellipse. So it just depends. So that one really wasn't there, so it would be a circle. So you can see those are very quick. So when you get to the assignment today, I think the last 7 or 8 problems are just like that. So it seems like a lot of problems maybe when you write it out, but it actually is going to go really fast. So that's one kind of big idea. The second big idea then, other than being able to classify a conic, is the asymptotes of a hyperbola. You probably noticed when you did your homework last night and you checked your answers, which hopefully you are doing, that they wrote the equation of the asymptotes differently than you did. You probably wrote your asymptotes as 2 different equations saying y is equal to, just for an example, 1/2 x minus 1, and y is equal to negative 1/2 x plus 3. And they wrote it as y is equal to, and I'm just making up numbers here, 4 plus or minus 1/2 times the quantity x minus 3. They kind of combined them together. The reason that they did that doesn't make them better or doesn't make what you did worse or anything. What you did yesterday was fine. This is maybe just a little bit quicker. And this is an equation for the asymptotes of a hyperbola. So if what we did yesterday makes sense to you and you don't want to try to memorize another equation or have to write down another set of steps, that's fine. You don't need to do that. If you want, you can go ahead and use this. It's actually really quick and really, really easy, and I'll show you when we get to those 2 examples. So the equation is y is equal to k plus or minus, notice on this one it's b over a, this one it's a over b, and then it's times the quantity x minus h. Really what you're doing is something very quick and easy. What is k? If you look at the standard equation for a hyperbola, k, it's the y value of the center. And assuming the equation is in standard form, you can look at it and you can see it immediately. I'm going to jump past the b over a and the a over b. Next thing I look for is this x minus h. What is that? Just because it's easier. If I'm looking at this equation, it's this. That's the x minus h. It's actually that parenthesis. I take the square off of it. So I don't know how best to say it. It's the x parenthesis, if you will. It's the x parenthesis. Take the square off of it. And then here's what you just have to focus on. It doesn't matter whether this is b over a or whether this is a over b. They both stand for the slope. So if you were going to actually memorize this as an equation, this is what I would recommend that you memorize. It's y is equal to k plus or minus, I would just say slope. And then it's times the quantity x minus h. And that would be one nice equation. They are basically saying the exact same thing. I'll tell you why it's b over a and a over b. It just depends on the equation that you're looking at. So now when we come down and we look at the examples, letter A and B here, I've got them side by side. And when you look at it, like I said, K stands for the y value of the center. I can see the y value of the center is 3. So I would say y is equal to 3 plus or minus. I'm going to leave the space for the slope in just a second. The x parenthesis is x plus 2. You literally just copy it down. And now the difference between these 2 problems is, do you notice the y value is the first term, where over here the y value is the second term? Remember, slope is always rise over run or y value over x value. That means over here, technically, A is 9 and B is 5. This is actually A over B because A is the first term, the positive term, and it happens to be under Y. So this would be 9 over 5. Again, that's A because this is, and that's a Y term, so the Y term has to be on top. Over here, we're saying that A is 6 and that B is 8. So when I go to write my equation, I'm going to say Y is equal to, looks like the center of the Y value of the center anyway would be -1, plus or minus my slope. There's the Y value this time. It's technically B over A. So it would be 8/6, or if I simplified that, it would be 4/3. And then the X parenthesis, you can just say X. You don't have to say X minus 0. But that would be the equation. You can see that is very, very fast. You basically look for the information in the equation, you write down the answer, you're done. You don't have to worry about plugging and chugging to figure out what B is. This will cover it. So if you want to leave your answer like this from here on out, that's great. That's the way the book does it because it's so much faster. If you still prefer to do it this way, that's fine. There's nothing wrong with that. It gives you the same thing. If you change that to +4/3 and distribute, combine like terms, change it to -4/3, distribute, combine like terms, you'll get those two answers that you normally write. But make sure that you understand why this one is A, B, and why it's A, because that's Y over X, which is B. Where over here, it's B over A. I'm going to need that for this last example that we're going to do. So I previewed it after we got done with this first one, but I said that they gave us the vertices and the asymptotes. You're going to notice this question is very similar. They gave us now the foci and the asymptotes. So I know I'm kind of going to be doing the same thing. So they gave me both of something, so I'm going to use those two things, and I'm going to figure out the center right away. We've always said if you have two of whatever it is they give you, find out the center immediately. I can see the X value is not changing. It's staying as a 2. I can see the Y value changed, and probably pretty easy to see that the midpoint there is 0. But add them together, you get 0. Divide by 2, of course, you still get 0. There's the center. Because these are the foci, it's the C value that it's giving me. And if you look at the Y value, since that's the one that's changing, the distance is 6, regardless of which one you look at. So I know C is 6. And since this is the foci, it's telling me that it's opening, since it's the Y value that's changing, it's opening up and down. In other words, I'm saying that Y is the positive term, which means it needs to be first when I go to write my equation, not second like that one. All right, so I got all the information I can from the foci. So if I go to set up my equation, I know the center is X minus 2. I made a mistake already. This is Y is the positive term, so the Y squared term has to come first. So I can just say Y squared or Y minus 0 squared divided by something minus, there's the X part of the center, X minus 2 quantity squared divided by something equals 1. If you did like I did, let's say you go to write this out and you have it accidentally like this. This is just standard form. There's nothing wrong with saying, oh, I can just switch the signs. You just have to understand that that's the positive term then. So I'd prefer you do it like this, but obviously there's nothing wrong with that. Addition, you can change the order. All right, so now I've got it in standard form. Now the difference between this first problem, once I set it up, I already knew what A was, so the only thing I was missing was that one number. Problem here, I don't know either one of these two. I do know that this is A squared, and this is B squared because that's the positive term. So I'm done with the foci. I now move on to the asymptotes. We said on that last problem, when you're dealing with the asymptotes, it's only the slope. Well, doesn't matter what form they give it to me in. There's the slope. So I know the slope of the asymptotes is equal to, remember we said you could realistically ignore the plus or minus. It's equal to the square root of 3 over 3. Now you can leave it like that, or you might remember, wait a minute, that number inside the radical is the same as the number on the bottom. That's been rationalized. I can unrationalize it if I want to. It really doesn't make a difference. It's not going to change anything that we do. It just might make the numbers a little bit easier to deal with. So if you don't catch that, not a big deal. All right, here's where it's different. Okay, great. I know that the slope is equal to plus or minus 1 over the square root of 3. The problem is I don't know A or B. I do know for a fact, though, that the slope is going to be, since that's Y, it has to be A over B. I know the slope should be A over B. Problem is, me setting A over B equal to 1 over the square root of 3 doesn't really do me a whole heck of a lot of good, because I'm still missing two numbers. I'm missing a and I'm missing b. I can't just assume that a is 1 and b is the square root of 3. It could be that this is 2 and this is 2 square roots of 3, or 5 and 5 square roots of 3, or -7 and -7 square roots of 3. You get the idea. So what am I going to do if I don't know? Well, here's what you do. I happen to know c. If you ever have an equation and you're asked to solve, like this one, and you're asked to solve but you have two variables, it means you're dealing with a system of equations. I need another equation with those same two variables, and that's where the foci equation is going to come in. So now I got to think, okay, wait a minute. Am I dealing with a hyperbola or an ellipse? It's a hyperbola. So the equation would be c squared is equal to a squared plus b squared. So c squared is 36. A squared is just a squared because we don't know what a is, and b squared is just b squared. We don't know what that is. So now what you are going to do is you are going to take this equation, which has got the a and the b in it, and you're going to take this equation, which has a and b in it, and you're going to solve. Substitution is going to be the best method here. I'm going to cross multiply to do this. And so when I do that, I'm going to get b is equal to a square roots of 3, or the square root of 3 times a. And I'm now going to make a substitution. If I know b is equal to that, I'll plug that in for b. So what that's going to do is that's going to give me 36 is equal to a squared plus b is actually a square root of 3 squared. So I can say 36 is equal to a squared plus, those are multiplied together. So this isn't a FOIL situation. This is square them both separately. It's going to be 3 and a squared, so it's going to be 3a squared. And then, of course, these are like terms, so go ahead and actually add them together. You're going to say 36 is equal to, that would give me 4a squared. Divide, remember you're solving for a squared eventually. Divide by 4, and I know a squared is actually 9. So I can come up here and put a 9 up there if I want to. I'm almost done now. I need to know what's b squared. So if you know what a squared is, go ahead and plug it right back in here. I can say 36 is equal to a squared, which I know is 9 now, plus b squared. And I'll just subtract. If I subtract, it looks like I'm going to end up with 27. Of course, you can take the square root of both sides by accident. You probably do it anyway. Or you can plug a squared in here if you want. If you had to take the square root of it, put the 3 in there. But either way you do it, you're going to get that b squared is equal to 27. And now, there's your equation. So very similar to that first problem. The difference is they gave me both foci. So if you're worried, oh my goodness, when do I need to make a substitution and when not, make yourself a little note. The only time you should ever have to do that is if they give you the foci and the asymptotes. If they give you the foci and the asymptotes, you're going to be dealing with the system of equations. If they give you anything else in the asymptotes, you won't have to. All right, that is the notes for 10.4 day 2. The two big takeaways from this one is make sure that you can classify a conic, and then up to you whether you want to use the equation for the asymptotes of a hyperbola or not. All right, best of luck with your homework. Again, please make sure that you're emailing if you have questions.